This is my review for the Stanford CS336 course, and it is for the language modeling. My background is purely in mechanical, so I don't have much basics in the computer science or IT. But my brother told me to have a look at this course, and it is really helpful that Stanford had put out all the course and in full length. I have gone through only one lecture till far, and it is around like hour and 20 minutes. So it is long lecture, and if you wish to watch it, you can watch it on YouTube. It is available for free. And if you want to go for the course from the Stanford, you can go for the course, but it is gonna cost you around like $8,000. And there is also other fees as well if you wanna go through them. So it can go up to around 25 grand. So if you're into that, go for it. I'm not into that. I'm just going to stick to the YouTube videos. And this is my first lecture, so let few things that I'm going to tell you as well that I knew a lot of the chunk. I did not understand a lot of the chunks, but I went through few things. You can also Google the things if you find them interesting. For example, in a language model, there are few things like attention, MHA, FFN, and logit. What are those? And what is flop? So flop is just floating point operation. The basic single mathematical operation is one flop, and whenever you talk about that uh, 10 to the power 25 flops, those are very high operations, higher number of operations. For attention is like that a particular weight is given to one word by the model. And then there is MHA, multi-head attention, and there is FFN, feed forward network, and there is logit. Logit is like the probability score for the final result. For example, if I give the chat GPT or any LLM model with a cat is sitting on a blank, so for the blank, there will be a competition, and the blank can be answered for a chair, a table, and a mat. So the model will give all these answers a probability score. Okay, what answer would fit much better there in the context. So that is the logic. It is also very deep, and also this is my first lecture, so this is what I have learned so far. So and also the thing is, there are a lot of new things. This is the that I am going to learn, and also you can learn as well. And so the interesting part is, so all the coursework is that it is in generally in Indian institutes, what the professors and all the other teaching guides do is they share a PowerPoint presentation. But this is not a PowerPoint presentation. This is literally a Python program. It is a Python file. If you look it up, it is .py, and it is not just he named it .py. It works. That is interesting. And there is one more thing is that tokenization and how that thing works. For you can see how I can write again. Uh, I I am Avnish. Now I am 25. Now I am a mechanical engineer. So for all these things, there will be a score, and these will be converted into a token. For example, like if you write something and there are like thousand bytes, but when you convert them into token, it can convert from 1,000 byte. You can go to like 500 to 300 bytes. So there is lots of data save you can do there, and it's also the I let's see. Okay, instructors is Percy, and all these are CA. And so when talking about the tokenization and tokenizer, Percy recommended a small YouTube video, and by I think by it is Andre Kapathi, very small YouTube video, just 2.5 hour long, just on the tokenizer. I haven't watched it, but I will soon. Let's see. And all the things, few things are GitHub code is available if you want to do the assignments. And there is, I haven't checked this out. Codes are available for assignments, all the things, and few research paper that are mentioned in this lecture. First is measuring the algorithm efficiency. This is by OpenAI. So I knew about that OpenAI published few papers, but I didn't know they published heavily and all they share a lot of research. So this is for the how algorithms improve the efficiency from 44 times between 2012 and 2019. So just by algorithm, because when you work on a problem, so if you are working on a model, so you want accuracy, na? So accuracy can be achieved by a formula of efficiency into resources. The resources are defined. Whatever laptop or compute power you are allotted, and whatever budget you are given, data you are provided, that resources are limited. But you can improve the accuracy by increasing the efficiency. And how you can improve that efficiency? By using much better algorithms, much efficient algorithms. So by algorithms, so they increased the efficiency for 44 times. That's great. I am going to read this paper. Hope so. And then there was second paper for model parallelism, and I was just intrigued by Raj Bhandari and all the other guys. And then the third paper is by Google. This paper is by Google, and what the Percy told is that this is like the very early version of ChatGPT and the chatbots that we have now. For example, you give an input in a string, then you get an output in a string. That was the early version of it, and it was published in 2019 or 20, I guess 20. So the OpenAI, the work ChatGPT is, these are later results of these papers. And also one more thing is, I was confused. So if you don't know what RL algorithms are, that they are just reinforced learning. Percy initially described as RL algorithm. I was like, what is RL algorithm? Reinforced learning. So this is my take, my review. Uh, so far, great learning. I haven't learned a lot of things because I don't know a lot of things, and four few things that I want to tell you guys as well, because I didn't knew them. So you guys should know. So you need proficiency in Python. You should learn Python. Experience with deep learning and system optimization. I don't know that. I'm going to check it out. College calculation, linear algebra. I hope you guys know it. Basic probability and statistics. I hope everybody knows this. Machine learning. I know the concept. What is machine learning? But I haven't taken a deep dive into it. I am going to, because there is lots of learning. So I hope that this was my review. So that's it.